Welcome to vpod.ai. This deep dive is sponsored by Stonefly. They're a leader in enterprise storage, backup, and disaster recovery, AI storage, and cloud solutions. If you are looking for secure, ransomware-proof storage, then Stonefly sells air-gapped and immutable storage. Just contact sales@stonefly.com to schedule a demo. Okay, so let's unpack this. We're diving into Apple's big M5 chip announcement. They're calling it the next big leap in AI performance. Our mission today really is to look past the shiny marketing stuff, get into the actual silicon, the architecture, and figure out how this one chip fundamentally changes AI, graphics, and, well, what we should expect from our Macs, iPads, even Vision Pro now. We're seeing these headline metrics suggesting AI on the device isn't just coming soon, it's here.
Absolutely. And I think the foundational thing to grasp, maybe even before we count cores, is the architectural shift here. This isn't just, the usual speed bump generation to generation. This system on a chip, the SoC, it feels like it's been engineered from the get-go with AI workloads front and center. Plus, it's built using that third-gen 3-nanometer tech. So right away, you're thinking density, power efficiency gains.
Okay, that focus on AI, it leads us straight to maybe the most surprising bit, architecturally speaking, which is inside the GPU, right? The M5 has this new 10-core GPU architecture, fine. But the headline isn't just the core count, it's that they've apparently built a dedicated neural accelerator into every single GPU core. Now, for someone who follows this stuff, why is putting that accelerator in the GPU, which is already good at parallel stuff, why is that so much more significant than just having a separate, powerful neural engine?
Well, it fundamentally changes the game for those really big, data-heavy machine learning models. Think about running, say, a huge 70 billion parameter LLM or generating a complex image with a diffusion model. These are just massive parallel tasks. Historically, even on powerful chips, you'd be shuffling data between the GPU memory and the dedicated AI core, the neural engine. That adds latency, it adds complexity. By putting a neural accelerator inside each GPU core, they've basically fused the pipeline. The GPU does its parallel number crunching, and right there, the results get accelerated for tensor operations. It's a much shorter path, much higher throughput.
And the performance numbers they're claiming that stem from this, they seem, well, almost unbelievable when you focus just on AI tasks on that GPU.
They are staggering. We're looking at over 4 times the peak GPU compute compared to the M4 chip. And if you go back to M1, it's over 6 times the peak GPU compute power, specifically for AI tasks. What this practically means is the raw power for running things like open source models locally is just dramatically higher. You're not necessarily hitting the cloud for stable diffusion, image generation, or, complex local coding help anymore. You can run them fast, right on the device using platforms like, say, WebAI or LM Studio.
Okay, but let me push back slightly. We hear 4x, 6x. That's usually peak burst speed. Given what we're talking laptops, iPads, thin devices, how sustainable is that kind of performance? Or is it just for quick bursts?
That's always the crucial question, isn't it? And yes, those are peak figures. But the architectural balance actually helps sustain it better. Because you've got the efficiency cores, you've got the main neural engine handling background OS stuff. That peak GPU power is more available for those big tasks you start. And remember the 3-nanometer process. It's inherently more efficient. So that performance cliff, when things heat up, it should be much less steep than older chips. It allows for longer periods of heavy AI use in pro workflows.
Right. And for developers actually building the apps that use this, how easy is it to tap into? Are they rewriting everything?
No, that's the smart part. It's designed to integrate pretty smoothly into the existing Apple developer world. For many devs, they'll see acceleration just by using the standard tools, Core ML, Metal Performance shaders. But the key thing for those really wanting to max it out is the new Metal 4 framework. It includes specific Tensor APIs. This lets advanced developers talk directly to those new neural accelerators in the GPU. Really fine-grained control over that power. That's how potential becomes real-world speed.
That deep integration is definitely key. Okay, so M5 isn't just AI, right? The normal parts of the chip, the CPU, they've gotten upgrades too. We're hearing claims like world's fastest performance core. What's the substance there?
Yeah, the CPU setup is up to 10 cores, looks like 6 efficiency cores, and up to 4 of those high-performance cores. And while AI gets the spotlight, the CPU itself is noticeably faster for general computing. They're quoting up to 15% faster multi-threaded work over the M4, that world's fastest claim. It refers to the raw speed and efficiency of a single one of those performance cores against what else is out there in mobile chips right now.
But again, the practical side, a super fast core in a thin laptop. How well does it sustain that speed? Can it handle like an hour of compiling code or rendering 4K video without throttling way back?
That's really been the core design philosophy for Apple Silicon since the M1, and M5 seems to push that further. The 3 nm efficiency is huge here. And think about it, by offloading a lot of the constant low-level AI stuff to the dedicated accelerators in the neural engine, the main CPU cores actually have more thermal budget left. They can run faster for longer when you hit them with those demanding tasks like rendering or compiling. It's sort of a whole system thermal strategy.
That loops us back nicely to the AI specialization. If the GPU now has these powerful neural accelerators built in, and the CPU is faster, what's the job of the dedicated 16-core neural engine, the NE? Is it redundant or is it doing something different?
Definitely specialization, not redundancy. It's a really important distinction for listeners, I think. Think of the NE as the super efficient, always-on AI brain for everyday tasks. It's optimized for low power, low latency stuff. Things like real-time image classification, indexing your photos in the background, predictive text, powering the core Apple Intelligence features. It sips power while doing that. The new GPU neural accelerators, on the other hand, they're built for high throughput, maybe slightly more latency-tolerant heavy lifting that you initiate, like training a small model or generating a really complex image. Tasks where you explicitly ask for something computationally massive, and you're willing to wait a second or two while it uses more power in a burst. So they work together. The NE handles the constant subtle AI. The GPU accelerators handle the big explicit AI jobs. M5 feels like the first chip where all the compute blocks, CPU, GPU, NE, are really sharing the AI load intelligently based on what's needed.
And getting the data to all those processors quickly. That's where unified memory comes in. Always been an Apple Silicon strength, but M5 ramps it up again. This is the highway for the whole chip, essentially.
It really is. The unified memory bandwidth on M5 is now 153 gigabytes per segment. That's almost 30% more than M4, and yeah, more than double M1. But it's not just the speed number, it's the unified part that's crucial, especially now with these huge AI models.
Explain that. Why does unified and fast matter so much to me running, say, Photoshop?
Latency. Plain and simple. When you run a massive AI model, its parameters, the weights, they need to be accessed constantly by the CPU, the GPU, the NE, maybe all at once. On older systems, you're copying gigabytes of data between separate pools of memory for the CPU and GPU. That's slow. It's a bottleneck. With unified memory, everyone accesses the same big, fast pool. Data doesn't need to be copied nearly as much. Latency plummets. That's why the new MacBook Pro, iPad Pro, with up to 32 gigs of this fast unified memory, can run these enormous AI models completely locally. It lets pros juggle demanding apps, think complex Photoshop layers and Final Cut Pro timelines, while maybe having local AI tools running smoothly alongside.
Okay, shifting gears slightly. Beyond raw compute, the visual output. If I'm a gamer or a 3D artist, what's the tangible graphics improvement here?
Well, overall graphics performance gets a nice bump up to 30% faster than M4, maybe 2.5 times faster than M1. But the architecture is smarter too. It's got Apple's third-generation ray tracing engine. That's a big deal for visual realism. They're claiming up to a 45% uplift in graphics performance, specifically in apps using ray tracing.
Oh, 45% just for ray tracing.
Yeah.
That's significant for realistic lighting and reflections. What makes that jump possible?
It's a combo. Dedicated hardware acceleration for those complex ray calculations, plus something they call second-generation dynamic caching, which has been re-architected. Dynamic caching is basically smart, real-time memory allocation within the GPU. It gives a task exactly the memory it needs when it needs it, avoiding waste and bottlenecks. That combination is what leads to visibly smoother frame rates in demanding games. They mentioned Cyberpunk 2077 and faster final render times for visual effects pros.
And this is where the chip's flexibility really shows, because it's not just in laptops, it's going into the Apple Vision Pro too. How does all this power translate into a better spatial computing experience?
Yeah, for spatial computing, things like visual fidelity and refresh rate are absolutely critical. You need smoothness to avoid eye strain and maintain that sense of presence. So in the Vision Pro, the M5 helps by actually rendering about 10% more pixels on those micro LED displays. Sharper image. But maybe more importantly, it pushes the refresh rate up to 120 hertz. That means much crisper details, smoother motion, and way less motion blur. Vital when it's tracking your eyes and updating the world constantly. Plus, those core Vision Pro AI features like generating your persona or turning flat photos into spatial ones, they just run faster and more efficiently, which helps battery life too during intense use.
Okay, so we have this architecture built around AI everywhere, super fast traditional compute, massive memory bandwidth. Where can people actually get this chip? And when?
All right, the rollout. M5 is launching in the higher-end products first. So the new 14-inch MacBook Pro gets it, the next iPad Pro, and the Apple Vision Pro. And the availability. All three were announced and went up for pre-order basically today, October 15th, 2025. So if you had to boil down the M5's identity, it's really defined by that strategic specialization. It's embedding AI compute capability, not just in the NE, but right into the CPU and GPU cores as well. The whole architecture is geared towards maximizing localized, power-efficient AI processing. That's really shaping what these devices can now do.
And that power efficiency point. It's not just about battery life, is it? It ties into their bigger environmental goals. The M5's efficiency helps these powerful new devices meet Apple's energy standards, which is part of their whole Apple 2030 push for carbon neutrality across everything they do. It shows performance and efficiency really can go hand in hand.
Absolutely. And this leads to maybe a final provocative thought for you, the listener, to chew on. We're seeing this huge leap in the ability to run really complex AI LLMs, diffusion models, right on the device itself, thanks to this memory bandwidth, these accelerators. So if the device in your hand or on your desk can suddenly handle sophisticated image generation, translation, coding assistance, almost instantly, locally, how might that change how much we rely on the cloud for those common tasks, maybe just in the next year or so? Could the desktop be taking back the AI crown from the cloud?
Definitely food for thought. Okay, this has been the Deep Dive. And remember, if you're looking for secure, ransomware-proof storage, contact Stonefly. They're leaders in enterprise storage, backup and disaster recovery, AI storage, and cloud solutions. Stonefly sells air-gapped and immutable storage. Contact sales at stonefly.com to schedule a demo. We'll catch you next time.